Hello friends, I am P. Sujatha, Assistant Professor, PG and Research Department of Economics, A.D.M College for Women, Autonomous, Nagapattinam. Now, we will see the topic Mathematical Methods in Economics. Now, in this module, we will see the role of mathematics in economics, definition of set, types of sets and operations of sets. Role of mathematics in economics. Mathematical economics is a model of economics that utilizes math principles and methods to create economic theories and to investigate economic quantities. Mathematics permit economics to conduct quantification tests and to create models to predict future economic activities. Mathematical economics is the application of mathematical methods to represent economic theories and analyze problems posed in economics. It allows formulation and derivation of key relationship in the theory with clarity and simplicity. By conversion, the applied methods refers to those beyond simple geometry such as differential and integral calculus, difference and differential equations, matrix algebra and mathematical programming and other computational methods. Now, in this module, we will see the definition of set. A set refers to a collection of distinct objects. Any well-defined collection of mathematical objects can form a set. Set is a basic concept in mathematics. It is a term used for a collection of things with some common characteristics. The members of a set are known as elements, and the elements are distinct and distinguishable. Symbolically, a set is represented as follows. If S is a set of first four even numbers, it may be denoted as S equal to 2, 4, 6, 8. Sets may also be infinite. Next, in this model to discuss the types of sets. The set is a well-defined collection of objects. Depending on the object and their characteristics, there are many types of set. First one is empty or null or void set. Any set that does not contain any elements is called the empty or null or void set. The symbol used to represent an empty set is empty set or null set. Example, let A equal to x such that x is greater than 9 and less than 10. So that x is a natural numbers will be a null set because there is no natural numbers between the numbers 9 and 10. Therefore, A is a null set. Next one example, let W equal to D such that D is greater than 8. D is a number of days in a week. Will also be a void set because they are only 7 days in a week. Next one type of set is a finite and infinite set. Any set which is empty or contain a defined and countable number of elements is called a finite set. Sets defines otherwise for uncountable or infinite number of elements are referred to as infinite set. For example, A equal to A, E, I, O, U is a finite set because it represents the vowel letters in the alphabetical series. Next, B equal to X such that X is a number appearing on the dice roll is also a finite set because it contains 1, 2, 3, 4, 5, 6 elements only. Next one example is C equal to P such that P is a prime number. So, it is an infinite set. The last example T equal to K such that K is a real number. It is also an infinite set. Next type of set is equal and unequal set. Two sets X and Y are said to be equal if they have exactly the same elements. Equal sets are represented as X equal to Y. Otherwise, the sets are referred to as unequal set. which are represented as x is not equal to y. For example, if x equal to a, e, I, o, u and h equal to o, u, I, a, e, then both of these sets are equal. Next one example, if c equal to 1, 3, 5, 7 and d equal to 1, 3, 5, 9, then both of these sets are unequal. Next, if a equal to b, o, y and b equal to b, o, b, y, then also a equal to b because both contain same elements. Next one, equivalent set. So what's mean by equivalent set? Equivalent set is nothing but those which have an equal number of elements irrespective of what the elements are. So, for example, a equal to 1, 2, 3, 4, 5 and b equal to x such that x is the vowel letters or equivalent set because both these sets have 5 elements each. Next one example, x equal to 1 square, 2 square, 3 square, 4 square and t equal to y such that x square is element of natural numbers are also equal sets. Next one type of set is singleton set. These are those sets that have only a single element. For example, E equal to x such that x is the element of n and x cube equal to 27 is a singleton set with a single element 3 and w equal to v such that v is a vowel letter and v is the first alphabet of English is also a singleton set with just one element a. Next one type of set, universal set. A universal set contains all the elements of the problem under consideration. It is represented by the letter u. A set of real numbers is a universal set of all natural, whole, odd, even, rational and other irrational numbers are called as universal set. So, next one type, power set. A collection of all the subset of a given set is called a power set of that sets under consideration. For example, A equal to A, B, then power set minus P of A equal to null set A, B, and A, B. If n of A equal to m, then generally n of P of A equal to 2 power n. Next, in this module, we will see the operations of set. Following are the sum of operations that are formed on the set. First one is union, intersection, difference and complement. Now we will see the union of set. Let A equal to 2, 4, 6, 8 and B equal to 6, 8, 10, 12. Then A union B represent as a set containing all the elements that belong to both the sets individually. Mathematically, A union B equal to x such that x is the element of A or x is the element of B. So, A union B equal to 2, 4, 8, 6, 10, 12. Here the common elements are not repeated. Next one set is the intersection of sets. An intersection is the collection of all the elements that are common to all the sets under consideration. Let A equal to 2, 4, 6, 8 and B equal to 6, 8, 10, 12. Then A intersection B or A is intersection B is given by A intersection B or A intersection B equal to 6, 8. Mathematically, A intersection B equal to x such that x is the element of A and x is element of B. So, next the difference of set A and B is represented as A minus B. X such that x is the element of A and x is the element of B. Conversely, B minus A equal to x such that x is the element of A and x is the element of B. Let us say example for a difference of set A and B. A equal to 1, 2, 3, 4, 5, 6 and B equal to 2, 4, 6, 8. Then A minus B equal to 1, 3, 5 and B minus A equal to 8. The set A minus B, B minus A and A intersection B are mutually disjoint sets. It means that there is no element common to any of these three sets and the intersection of any of the two or all the three sets will result in the null set or empty set. So next one in this model to discuss the complement of sets. If U represent the universal set and any set A is a subset of A, then the complement of set A will contain all the elements which belong to the universal set U but not to the set A. Mathematically, A dash equal to universal set minus A. Alternatively, the complement of set A, A dash is the difference between the universal set and the set A. So, next one, the subset. A subset is a set formed from the element of the set. For example, if n is a set of integers, then n include both positive numbers and the negative numbers. Symbolically, it can be represented as n equal to a set of 1, 2, 3, 4, 5 and minus 1, minus 2, minus 3, minus 4 and minus 5. Where the positive numbers may be grouped as another set, say P equal to 1 to 5 and the negative numbers may be grouped as Q equal to minus 1, minus 2, minus 3, minus 4, minus 5 such that both B and Q are subset of set N. So the formula used to find the subset of the set. A number of all possible subset of the set with n members is given by 2 power n. For example, if A is a set of 2 members or elements, then the total number of subset is 2 power 2 equal to 4. Thus, A equal to 1, 2 will have 4 subsets. That is 1, 2, 1, 2 and a null set. If F is a set of 4 members of a group, the possible subset or relationship that may exist may be given by the subset of the set. Thus, the total number of subset is given by 2 power 4 equal to 16. Thus, F equal to A, B, C, D will have 16 subsets. That's A, B, C, D, A, B, A, C, A, D, B, C, B, D, C, D and A, B, C, A, B, D, A, C, D, B, C, D and A, B, C, D, then null set. Next one, convex set. The convex set is the set such that given any 2 points in that set, the line join the 2 points lies within the set. For example, a solid cube is a convex set while a crescent is the non-convex set. In economics, indifference curve are normally convex in shape, which means that all the bundles of an indifference curve are equally desired and hence may be called a convex set. Next, the linear expenditure system. An example of the application of set in economics is a linear expenditure system. The expenses from different items consumed by the consumer may be grouped in sets such as food, clothing, furniture and travel. Each of the set is the element of universal set called consumption expenditure. If E represents the set of consumption expenditure, then E is a food, clothes, furniture, travel. Each of these elements in E, that is food, clothes, furniture and travel, will also have a subset. The set of food may have subsets such as fruits and vegetables, boiled, fried and so on. The set of clothes may have subsets such as summer clothes, winter clothes, casual and formal and so on. The set of furniture may have subsets such that wooden and steel, and the set of travel may also have subsets such that domestic and international travel. So each of the set is independent of each other. Thank you.